1-0 guys, this our third video we will try to add a support of PostgreSQL for our backend. And since the code base of the project is growing up very quickly, I can't keep coding in real time, as this will greatly lengthen the videos and slow down the development of a social network. Instead, I will briefly review the development steps and the problems that arose in the video, and you can find more details about the code directly in the project repositories. I hope this will not bring misunderstanding. Okay, as the first step, we need to install PostgreSQL and create a custom user in our database. So let's open terminal. If you are using macOS and Homebrew, you can install it in one command. Just type brew. I'm sorry. Oh my god. Brew, install, and PostgreSQL. I have it installed already, so I will skip this command. And to start or stop PostgreSQL, you can just use a default command construction, brew services, and start or stop PostgreSQL. I have it also started already, so we will go to the next step where we need to create a custom user. So let's type PSQL, our database name. And to see all databases we have, we need to type \l. As you can see, we have three default database: Postgres, template 0, and template 1. A fourth is not recommended for the production. I'm gonna use Postgres. This is a default database. However, let's create a custom user. Let's type create user admin and view encrypted password. And password will be admin2. I'm sorry, admin2. Okay, I have this user already. When you have created a new user, you also need to grant privileges to required databases with required permissions. For development, we just will grant all privileges on Postgres database. So you need to type grant all privileges on database Postgres to and our user to admin. Okay, this also we can close PSQL and close our terminal. Now let's go to the viewer. Where is it? Oh my god. Oh yeah. And I will show how to create a new connection to PostgreSQL database. Choose plus button and choose PostgreSQL. You can left all fields by default, but username and password. Here we need to type admin and admin. We can test connection. As you can see, we have connected. So you need to press finish. I have connection already, so I just will close this window. And if we will go to our database and show tables, as you can see, we have no any tables. So before we will create it, let's switch to our project. But firstly, let me to show you how you can track what changed between the previous video and the current one or next one and so on. We need to go to the server repository and switch to text section. For example, we will choose the current episode 3. And now we can compare it to the previous one. Just choose episode 2. And we can see all changes, what's happened from the previous episode. Well, we are in the project, and as you can see, there are a few new dependencies for the database and for the dependency injection. If you haven't worked before with the dependency injection, then it will be easy for you to understand on real examples of what we will look at a little later. For this moment, let's focus on database dependencies. First, we attached Hickory pool, what will manage for us database connections. and exposit core, what will abstract our queries from PostgreSQL dialect. And Kotlin datetime. Kotlin datetime package is required to work with Kotlin's datetime dependency, with Kotlin's datetime library. Also, we have connected Exposed JDBC as required package and PostgreSQL JDBC driver. I think that's all changes. And let's switch to application config. As you can see, there is new section database and subsection connection, where two new attributes what are duplicated. When Ktor loads application config, it automatically will replace default values by system environment variables, db euro and db pool if they are set. Okay, now we can drill down into the code. You may also have noticed what we have db migrations package, but we will return to this package a little later. For now, let's just open Kotlin and our main package. I think we will start from the domain entities. As you can see, we have new entities. For example, let's open new user, user update, and page. Oh, and light user. All these entities are required to work with user collection, what we will store in the database. So new user for creation, user to fetch user profile, user update to change user data, and a page for pagination. And the last one is light user. Light user is used for pagination to fetch less data. The situation is similar with all our entities, but let's take a look at the diagram of the clean architecture. Okay. As you can see, the entities are a core of the clean architecture and all outer layers can depend on them, but not vice versa. However, if we will come back and we'll check our imports, we will see what we have an import for Kotlin serialization package and, for example, for Kotlin datetime package. Here we need to remember what near the clean architecture nor any hour is an unshakable law. Architectural patterns are guidelines what should help with the development, not create additional problems. The dependencies what I used here are close enough to the standard Kotlin library and perform very specific little functions. So we can move away from the clean architecture and accept them as standard building blocks from which we will build our app. During the development process, you will notice what I will periodically deviate from the clean architecture or the database normalization. This will be a conscious choice to increase performance or to simplify the development and maintenance of the solution. Well, we can close our tabs. Yes. And let's switch to the use cases. I will open something, for example, get users use case. And as you can see from the code, at this moment, they're just wrappers for calls of a database gateway methods. Therefore, it may seem what were redundant and can be removed from the project. Now it's true, they don't carry much useful payload, but this layer will abstract us from our dependencies in roots and make testing easier. Also, more complex business logic of the application should be implemented in this layer. That's why this layer should not be excluded. Okay, let's close it, and finally we can go to gateways. Returning to the clean architecture diagram, you can see what were no gateways, only repositories. However, the term gateways is used in the original diagram. And this is a bit of a hollower topic, because strictly speaking, the gateway pattern denotes a channel, but in the clean architecture, a repository or gateway is understood as an interface for interacting with some kind of data sources. Considering what we have methods to connect to the database, in iGateway interface. In my view, gateway name seems more logical. Well, let's switch to iDatabase Gateway. This is a strong side of the clean architecture because we can focus on a core development. We found implementing, data sources or presentation layer and so on. And also for data sources and for presentation level, we can develop them independently. All what we need is just to define required interfaces. However, let's focus on an implementation of PostgreSQL support. As you can see, iDatabase Gateway defines few methods to interact with our database. The implementation of these methods is located in data gateway db package. So let's open database gateway. In the initialization block, we set up Hikari pool, and later in the connect method, we tell to Exposed framework to interact with our database using Hikari pool data source. Honestly, there's nothing interesting in this implementation because all these queries are just standard queries in Exposed DSL framework. But one interesting moment, if you find some paginating method, for example, one second. Okay, for example, get comment page. We can see one attribute of page entity, next, and a parameter since in the method signature. If you have worked with SQL, for example, with PostgreSQL dialect or with some another one, you may know some construction like select, for example, all from some table. And later we can use offset and limit m for pagination across our result. However, this approach is not suitable for mutable tables because we may lose some results during the pagination. To prevent this, we can use some key that will allow us to fetch the next page. And as you can see in this query, we just use primary key and filter query results to it was greater than the last primary key, and specify a limit for this. Of course, this approach has disadvantages too, and for example, we can't sort our results set by a some attribute but primary key. However, it's okay for the current stage. I think everything is transparent enough here, so we can go directly to the presentation layer. Let's close database gateway. I will fold all these packages and let's open the presentation, routes, and for example, user routes. What do we see here? Some kind of black magic happens and we got a decided use case and call its invoke method. Now is a good time to remember about the dependency injection package, what we skipped at the beginning of the video. First, let's open application. As you can see, we have a new method called install.di. Install.di is defined in the dependency injection Kotlin file, so let's open it. Here we tell the KDE how to initialize the objects we need, so later we only need to specify the interface or class of required object, and the KDE will return this object to us. In fact, somewhere in the barrels of the dependency injector, all the necessary information for initializing the objects we need is globally stored. First, calling our DI in another part of the program, we refer to this global definition and get a decided object. So there is no black magic. Finally, let's go back to the DB migration folder in the resources and where two scripts. One to upgrade our database to the current version, and one is for downgrading. If we open them, we can see it just poor SQL, poor PostgreSQL. You can learn them in details in project repository, but I would offer to execute them and build AR diagram. I think it will be much more clear to understand our database schema. So let's go to the viewer and we'll open our upgrade script. Let's open it automatically. Okay, let's go to open file, to our folder migrations, and we'll choose upgrade migration script. Let's open this and press execute script. Okay, has been executed. So let's refresh our tables. Okay, refresh. And we can see few tables, including dbinfo. dbinfo is a system table. We just store our database version here. Okay, let's build ER diagram. And now we can see clearly our database schema. We have users. Users can have different gender. User can write some post, they can write comments, or they can put likes for comments, or they can put likes for posts. Just very trivial database schema for social network. I think now we can start our server. Let's press run. And we will try to perform some request to our server. Let's create a new user. And we'll try to execute our request. Okay. Well, we have created a new user. If we will go to our database now, let's open user tables. And we can see a created user. That's all. Thank you for watching and see you in the next videos.